Hello everyone, so welcome to my channel. So we have already covered the logic for this rabbit house problem. So we'll now check out the coding. Okay. So here we, as I discussed in the previous video, we require a heap queue. Okay. So from this model we are using a priority queue. So also for this problem to understand, you need to know what is priority queue, and you don't just if you don't know what is priority queue, just I would recommend just you go to YouTube or Google and just find out what is priority queue and what are the syntax used in heap queue. Okay, so here the code starts from here. Okay, will come back to this two functions later. Okay, first we'll define the directions. So we have 0 1 downwards, 1 0 upward, and then minus 1 0 and 0 minus 1 left and right. Okay, and this is the output variable, box is equal to 0, and we'll calculate this at the end. So here what we have is for every test we are reading this row and column, and we are reading this every rows. Okay, so for example for this case we are entering every row, and we have to create a duplicate also. To create a duplicate, I mean, for a simple one-dimensional list you can directly use this colon operator, but for like two-dimensional you have to use list comprehension and copying every row. Okay, and then here we have this priority queue and entry finder. Priority queue is nothing but the list only, but we are the structure which is the priority in this list is saved is the priority queue. Okay, that is which the to update this value and remove value from here, right, we use a heap queue module. And we have dictionary to get, I mean, I name it as like entry pointer, so that we can save this value. For example, if you want to save this value, we save it as like a 0 0 and 0 0 is equal to 0, and that is the key. 0 1 key is equal to 0 value, 0 2 key is equal to 0 value, 1 0 is equal to 1 0, and 1 1 is equal to 2, and like that. So we are saving this all these values in a proper format in this entry finder. Okay, and we are adding, okay, for every whatever value we have in this matrix, we are adding it to priority queue and entry finder. For that we have this add task function. Okay, and here when we add this task, what happens is like we have the coordinate and the value. So coordinate is nothing but corresponding ij value. So, and as I told in the previous video, this value should be a negative of that corresponding value should be -2, because when we pop a value from heap, it will pop the minimum value. Okay, and to make the maximum value as minimum, so you have to just reverse the sign. That's why we are using this negative value, and we are creating a list here, the value and the coordinate, and we are pushing it to heap queue and to this heap. Okay, the priority queue heap, and we also save this value in a dictionary with the key as coordinates, and I'll come back to this point. Okay, and so now after that, for every value in the matrix, okay, so we are using this row into column. So okay, so for example here it is like a 9, so the range 9 means 0 to 8. Okay, and no need of actually like saving this some value in some number, just that's why I'm just using the underscore sign. Okay, so we have to pop the maximum value. Okay, so when we do pop task, okay, what we are doing is now I'll come back to this one, and I'll come back to this one. Okay, I'll explain the remaining parts, and then I will explain the what is this used for. Okay, so we are actually popping this using this heap pop method. We are popping the minimum value. Okay, so in this case it is -2. Okay, and we are getting that, and we are getting corresponding coordinates. We know that I mean value is not required, only coordinate is required, and we are returning that coordinate. Okay, and also when we pop, we have to delete the corresponding dictionary value also. Like we had a dictionary of 1 1 is equal to -2, that value we have to delete. Okay. The remaining code I will explain later again. Okay. And we get the coordinates here, and for this coordinate ij, for this ij, that's 1 and 1, we have to see all the neighbors. Okay, -1 +1 and 1 0 1 0 1. Okay, so everything we have to check, okay, for every direction. Okay, that's why we are doing it here. For all the four directions, we are checking. First, we have to check whether it's a valid directions or not. For example, if you are in an edge, or if you are in some any at the corner or in any edge, right? So then there is a chance that when you do plus zero, right, it will go out of the matrix, right? So that condition is being handled here, the here and here, okay, in x and y directions. And after that, also we need to find out whether the neighboring value is, for example, if you consider this 4, okay, and if this is a 3, then it's the, I mean, I'm not of going and doing anything, but if it is 4 and 2, okay, which is like greater than the neighboring value plus 1, then we have to update that value, okay, update the neighboring value with the, for example, the neighboring value, that this value with plus 1, okay, plus the current value, that is we are doing here, I plus, oh sorry, a minus 1, right? So this 2 minus 1 is equal to 1 here, okay, that's why we're doing minus 1, not plus 1, I'm sorry about it. And we are adding that particular updated value, that we have added this, updated this 4 values, right? And we have to add it to a heap again, because now we have to check that particular value, right? So we are updating it to a heap. So when we update to a heap, there is a possibility that, because since we already added this zeros value, and again we are adding one value, so it's duplicate, right? So we are checking whether we have a duplicate. If we have duplicate, then remove that. Okay, it is easy to remove it from dictionary, but not from the corresponding list. I mean priority queue. Okay, so to remove it, what we do, once we pop that value, we will get this, right, that corresponding list. We are updating the list, and this list is nothing but this is the exact reference to the list which is present in the priority queue. Okay, to explain this point, I have just given a simple example. Say that you have value and coordinates. Okay, and if you do a pop and update it to a different edition, different list, okay, this list and this list both are same. Okay, to demonstrate that, what I do, I just update the value of this list. So it will also, if you check the first initial list, there also it is updated. Okay, so this is one of the actually dangerous thing which can happen in your coding. Okay, so always when you use list, be careful about this. Okay, yeah, it could be sometimes not, I mean, you may not know that these things are happening internally, but it keeps on happening because the reference is always same. I mean, both are referring to the same object. That's why if you use this his operator, you see it as a true. Okay, that's why we are just updating in the large number of value, because heap pop always gets the minimum value. So just randomly we are updating some large coordinates here, so that that's unlikely to get popped up when there is a duplicates. Okay, and here in the pop task, what we need to do is, I think now I covered this part. Also, I think this I already covered, and here I think. When we pop the value from here, if the coordinate is equal to this value which we did, it is not required. Okay, we did not delete from here when we deleted the corresponding entry finder, so we are doing it over here. Okay, just, I mean, again that particular value we are deleting. I hope this is clear, I'm not confusing. Okay, and so so I think these two are the main tasks, main functions which are doing all the most of the activities. And then we are updating with also the new value. Okay, once you have popped up, for example, for this one, right, we are also updating with the new value here. Okay, pushing the new value which I showed you in last video presentation. Okay, and then once we did all these changes, then we are trying to find out the sum, which is nothing but the differences. First we have to find the difference between the two matrices, this original matrix and the modified matrix. Find the difference and sum all the values in that. Okay, for every row and column, then you will get that corresponding total number of boxes. Okay, okay, guys. I think that's it for this video. If you have any doubts, right, you can just feel free to comment in this video section. Okay, I'll happy to help you out, and I'll have placed this code also in the GitHub. You can just take it reference, and if it's helpful to you, you can just subscribe to my channel for our future notifications. Okay, thank you.